Hey, this is Kasamwani. Welcome to my YouTube channel. I make videos on machine learning research and coding interview questions. In this video, I will be going over a Leetcode problem that I've never seen or solved before and trying to go through my solution that I come up with on the spot and sort of just to show how I sort of problem solve and try to think about different solutions in a more natural sort of fashion to what you would see on other YouTube channels. And just to prove it to you that I've never ever solved this problem, you can see that I've never made any submissions yet. Yeah, and so that being said, please subscribe to my channel, and without further ado, let's solve this problem. So before solving it, obviously I have to read the question. We're given integer n, and we are supposed to return the number of strings of length n that consist only of vowels a, e, I, o, u and are lexicographically sorted. Okay, so let me just go through the examples first. So if n equals 1, we can only have 5 strings, a, e, I, o, u. If n equals 2, we can have a, e, a, I, a, o, a, u, e, a. Right, we cannot have ea because e is greater than a in terms of its ASCII value, and that's sort of the definition of the lexicographical order, where for any array the ith value should be greater than or equal to its I plus 1 value, or in other words, an array s I minus 1 should be less than or equal to si. So if you have a character a, its value is always, less than or equal to b, say b, and so these are in lexicographical, right? And the converse is false, obviously. And so that's our constraint, and yeah, looking at it, it seems to be a sort of a dynamic programming problem where we're trying to solve, where we're trying to find the total number of characters, or sorry, total number of strings for a particular value of n, and we're sort of doing it by solving in subproblems. And what I mean by that is when we're trying to find the total number of strings for n equals 2, it sort of is dependent on the value for n equals 1, because n equals 2 builds upon n equals 1. The reason is because you have a through u, and then you have a, e, AO, and so on and so forth, right? So these, the results on these depend on I minus 1, and we're trying to do it from I equals 1 through n. And just looking at it, you can see that A, so you have A, E, A, I, A, O, A, U. So when the current index that you're on is A, you can have up to, or you would definitely have 5 characters appended at the end. The reason for that is because a is of the smallest value, and so you would have all values greater than or equal to a, which are all the vowels in the English alphabet. But that is not the same for e, because for e you would have just e through u appended to it, and that's what we see over here. When we have e, we do not have a as its prefix or as its suffix. We have it only as its prefix. And for I, you will not have a or e. Let's see, A or E, and for U, you would just have U, right? So it feels like sort of a basic combination question where you have, for the first one, you just have what are those values are. For second one, it's -1, and then -2, and -3, and -4, and then -5. Oh, sorry, that's the sixth one. So you would have basically these 5 values. And yeah, so let's just solve this problem. Let's first create our DP table. And the initial value is 1, because initially you have all values have at least 1, right? A, E, I, O, U. And just looking at the constraints, the value of n should be greater than or equal to 1. So we would do for so going by the logic, let's see. So if we go by the logic, for A, we would have all these, and for E, we would have the ones after this. So it's basically saying for initially when A equals 0, we would have dp0 plus dp1 plus dp2 all the way to dp-1, which is just dp4. And that's equivalent to saying sum of dp j through the last character or last index, and I think so that would give us the number of instances for each individual character, right? So for A's and E's and I's and O's and U, and so we would just have to sum them all up, and hopefully that should make sense. Let's see. We have n iterations, and for each one of them, which is dependent upon its prior values, A through U, and this takes care of the lexicographical order and returns the sum of individual max or instances of all characters with length n. And that should be it. Let's test if that works. So we got the base condition right. For 2, we should get 15. Okay, yeah. And 33 should be 60,000 or 66,000. Awesome. All right, so I think it works. Let's just submit this. All right, so we did solve this question. Yeah, I honestly did not expect to come up with the solution so quickly. It was probably because this was a very simple question, and in terms of the time complexity, it's O of n, where n is the length number of characters we can have in the string, and space is O of 1. We're just making use of constant auxiliary memory, DP. DP always has 5 characters, so it's always constant space. And so yeah, so O of n, pretty optimal solution. Yeah. And yeah, that should be it for this video. If you enjoyed this video and you'd like to see more of these type of coding problems, do like and subscribe, and I will see you next week with another video. Peace.